Let's start with and thanks for the great introduction, Ganesh. I think I would like to start with the data and analytics and why it is very important for any organization. They have to transform themselves into this digital, as part of the digital transformation, and get into the data and analytics if they really need to survive in their business, with making them as a competitive company across the industry. If they want to compete with anyone in the market, they have to spend or invest a lot in the data and analytics so they can target the right people, right time for the right product to get a better profit for their company. So the data and analytics is becoming more and more important in any organization as part of their digital transformation. And Microsoft Azure and all the cloud technologies exist today in the market help them to achieve the desired goal what they want to go in. So I just want to start with why data is the new oil. If you are comparing, they are comparing the oil with the data, and the data drives the business today. If you look at it, if you want to optimize the sales, or you want to spot the trends ahead of the curve, not just after that, the trend started. Most of the companies started investing in their data collection and the understanding of their data even before they try to understand their customers' behavior to do the predictive and prescriptive analytics, and target the exact customers with the exact product so they can maximize their profit. So you can see there are various reasons why data is important for business and why the data is driving the business today. If the business wants to innovate, if the business wants to improve the customer satisfaction, or if the business wants to improve the decision making and take the proper decisions, all they need is the data. If the underlying data is not sufficient to make these decisions, the businesses are going to fail. And so far, with the traditional infrastructure available for the companies, it's very hard to manage it because of the nature of the data evolution. But now, with all the cloud technologies and the simplified operational mechanisms available in the cloud technologies, this will become more and more easy, also self-sufficient or self-driving factors for business, why they need to invest and start collecting more data to become successful in the market. So being said that, I would like to separate the data analytics or the landscape of the data analytics, how it was and where we are heading towards in the data and analytics spectrum. You can see here, there are four types of data analytics: the descriptive, diagnostic, predictive, and prescriptive. The prescriptive being the top-notch mechanism in the data and analytics world, where they can target every single customer with a specialized offer. I can give you an example that there was a big retail market in North America. They want to have a better sale in their gaming industry, or they want to sell more gaming consoles during the festive season, and they want to sell the proper gaming to their audience. So they started the data collection at least a year back to understand the different patterns of their customers, who buys what based on their web search collections. That if a users are going to the web and they start searching for the gaming information, and based on their Facebook and social media data, all this information got collected, and also they started having competitive information but from different retail markets across North America, which gaming console, which retailer is selling more on what time frame and what's the age group. So they started segmenting their customer base, and they understand the behaviors of the customers well in advance, even before the season starts, and they start promoting the customers in multiple ways. If you're very close to the perimeter to the retailer shop, they started giving vouchers that you can get $10 discounts if you're coming into the shop to buy some stuff. And if you are in the shop, they will give the bundled offers for you so that you can buy more than what you plan to buy. So these are the type of marketing and customer analytics today the companies are doing to target the each and every individual customer to do more shopping or to more purchase on their company to make their profit growing. So you can see here the descriptive, that's what the initial analytics, we can call it some sort of a BI, that the data comes in and it will be displayed as in terms of dashboards, Power BI reports, and so on. Then there is a diagnostic behind that data. why we are not selling when compared with the last quarter. For this quarter, what are the different factors influenced our sales? So mostly the diagnostic analytics started happening when they have more data and they can compare the data for the 5 years. Then they started predicting. So if there is a pandemic happens in particular month, this is what I'm going to save, this is what's going to be my impact. So I need to predict myself in for the future, then I can prepare myself. And also from the prescriptive perspective, they know what is happening. So we can start not predicting, also prescripting, this is what you need to buy. And I'm not sure whether you guys can see that on the market, on the food industry currently, there are lots of companies delivering the food industry or food to our doorsteps, but they also start influencing what we want to buy. Let's assume that if you are desired to have an Indian food for today, but there is an offer when you get into the Uber Eats or skip the dishes, there is an offer pops up. If you go and buy McD, we are going to offer all these bundled packages like your nuggets is free, your French fries is free, and your drinks is free. Your mind is changing from the Indian food, and you would like to get a burger from the McD because of those offers. So they started influencing what we want to buy because of the data what they have and the interest what we are showing towards those products. So this is the type of nature or the trend we can see in the industry across all the regions, whether it is a North America or a Canada or a US or Canada or Europe, India, you name it, all the countries or all the regions, all the companies is doing and investing a lot in data because this is the only way they can survive in their business model. Being said that, I would like to give a short intro on what is data. I think most of the folks are based on the surveys, you have already read what is data or have some understanding what is data, right? The data means it's a collection of facts, numbers, descriptions, objects, maybe stored in a structured. When I say structured, it's a table. So you can see here in the left hand, it's a table which has rows and columns, or can be a semi-structured where there are blocks and JSONs or XMLs and so on. And there can be an unstructured, which can be an audio file, video files, images, documents, and so on. The data can be in any format, but it can be collected and analyzed to produce meaningful insights. Then we get into the different types of data stores. So if you can see the data stores, because of the nature, how it's going to consume or how it's going to use, we can classify them into two categories. One is transactional, another one is analytical. If you can see the transactional, let's say that you go and do a transfer from your bank account to your friend's bank account. This is a transaction. You deposit, let's say $100 from your account to transfer to your friend's account. So there is a transaction, there is a debit, there is a credit, transactions are happening. But whereas when it comes to the online analytical processing systems, it's not just this transaction data, it also will have from which branch, what time, why, all those information also will be collected to make some better decisions on the online analytical processing systems. We'll see deep dive on this, each of the system, how they are different and why the people are started spending more on analytical, because the transactions can be one or many, but when it comes to the analytics, they want to consolidate all the data into a common data warehouse so that they can take a better decisions or better analytics on top of the data. So this is an example I have given earlier, that there is a transaction happens, and this is how the data will get represented in a transactional system. When it comes to the analytical systems, you can see the data sits in on-premise. So when I say on-premise, if you're working for a company XYZ, the company will have its own IT infrastructure, which has its own databases, applications, and so on. And all the data collected on those on-premises data store will get ingested, stored, processed, and visualized using the analytical and data tools. And the same thing goes for the cloud data. SaaS data like Salesforce, Microsoft Dynamics, and so on. And you can see lots of different icons to represent the data ingestion, storage, and processing and visualization. We'll go in deep on those, each of these topics later today as part of our discussions. And from the data perspective, the data can be a streaming. When we say streaming data, the data comes the moment it got collected, it gets streamed into this data store. Whereas in the batch, it will collected in the source and scheduled and transferred or shipped to the analytical warehouse in a scheduled batched manner. And I would prefer to take some questions if you guys have at this stage, so that we can continue with the rest of our discussions.
Yes, anyone wants, you can ask questions now. So far, whatever we discussed, you can unmute.
I just want to make sure that I'm not going very fast, as well as the concepts are very clear for everyone before we jump into the next topics.
So maybe I can ask one question, Siva. I mean, so this data, so really in the previous slide, it's an on-prem, it's everything, right? So do we need any programming language, anything to become as a data engineer? I should know any language specific. What is my prerequisites to work on this analytics area?
To be honest with you, we all are a data analyst by nature, right? If you're going to a shop, we know what we are buying, and we have already planned, this is our purchase amount, and this is what we are going to shop. So we do some planning, and once we're done, we do analyze, and also we do budget every month in our home to see this is our income, this is our expenditure, so we can be controlled on our amount. So that means we already started doing the data and the analytics. We also do the over time to time that what's our spending pattern and how can we reduce our overall spending in our daily lives. Okay. So by design, we have the data analytics and the data engineering, not through a system, but at least by design, we have this concept. Yes. Yeah, within ourselves. But so when it comes to the data engineering, do you really need any IT or kind of a development experience to do that? It's a kind of a mixed answer as an yes and no. But for the nature of the jobs, if you go with the data ingestion, there are tools which can does this job by just clicking the button, connecting to the source, and moving the data to the target. You don't need a programming experience to do this. But at the same time, if you want to analyze data in a greater extent, then you might need some little programming knowledge as a SQL or something to query the data to understand what is happening.
Yeah, yeah, thanks. Also, based on your description, I see that now any industries that has a data, right? Anything, whether I'm a web development or even IT, and non-IT domains also, right? Somebody is talking, that is also a data.
Yep. Yeah. And each of the systems. So it's not just only the analytics uses the data. Even if you're an IT support engineer, you have the number of tickets and how much time each ticket is taking to resolve. All those information is collected and aggregated to produce metrics to your organization.
Hey Shival, during this course, like the whole content, there's no coding or anything required?
No, that, as I said, it's based on the nature of the tools, and we will cover in depth on those topics where you have more programming experience, where you don't have a programming, you don't need a programming experience, where you can use tools to fulfill your task. We'll be covering that in the next few slides.
Okay, but the entire course for data engineering, there's no there's no section that requires coding. Is that what you mean?
There are few sections. If you want to go more in depth, you might need coding experience. If not, you don't need it.
Okay, so to pass the exam, I don't need. It's not a prerequisite.
No.
Okay.
That's not a good.
Okay. Being said that, I'd like to move on the next few slides. Yeah, and I just put together the different characteristics of big data because I just want to show the difference between the data versus the big data. We are in the big data era right now. You can see the data is coming in huge amount of data. So the volume is there, and there are variety because difference of format based on the nature of the data is collected from different sources. And there is a value on the data because we are extracting the useful information out of the data. And the velocity, the speed of accumulating the data, it's tremendous. And we are start receiving all this data every single second or a microsecond into the data platform. And if you can see the veracity, the consistency, inconsistencies, and uncertainty in data is also huge because of all these other natures. So these are the different characteristics of big data, and how we can overcome this challenge or use this benefit of big data to get a better analytics on any organization. That's what we are going to see in the next few slides. And this is something which Ganeshan touched upon as part of his slide deck. So there are different roles in the data. One of them, the core role, is kind of a database administrator who creates and manages the database, implements the security of the database, and also takes care of backups, access, and performance monitoring, and so on. And there is a next role, which is the core for our presentation today, which is data engineer, who build the data pipelines and process, and also ingest the data and prepare the data for analytics and analytical processing. So you can see here the data engineer role is more of building the data pipeline or the orchestrations to move the data from the point A, which is the source transactional application, to the point B, which is the analytical data warehouse system. And the data analysts who will try to understand the data, talk to the business users, get more insights to see how he can present this data visually so that everyone can use it for the analysis and get better benefit out of it. And if you can see the different tools by each of these roles, as a database administrator, there is an Azure Data Studio, SQL Server Management Studio, and the Azure Portal and CLI. As you said, I see here that there is no programming languages involved here, and most of these tools are provided by the Azure or Microsoft tools itself. From the data engineering perspective, then Azure Synapse Studio, which is the new and the latest third gen Azure data warehouse solution. They rebranded it as Azure Synapse. This studio has a portal which has an integrated data factory, also the Spark ecosystem and SQL ecosystem, in addition to the Power BI. So we can combine the data ingestion all the way to the consumption within the Azure Synapse Studio. The same thing goes for the SQL Server Management Studio and the Azure Portal. And this is for the data analyst. The tools, you can see it as a Power BI desktop to connect and produce the Power BI reports and publish them into the Power BI services, and use the report builder to have the paginated or data visualization on top of the Power BI reports. So we talked about the data, but we didn't talk about the data warehouse. We touched upon we will collect the data, aggregate, and store it in a centralized way. So which is called as a data warehouse. So we collected all the data from the various systems, and we accumulated and transformed the data and store the data into a centralized common aggregated way, so that everyone in the organization can use it, instead of having the data sits in silos within the organization to produce different report and confuse. Because of the nature of their sit in silo, they cannot produce the common measures across the organizations. So that's why the data warehouse is very important for every single organization. And we will see what is the traditional data warehousing, how it was done up until now, and how it is evolving with the help of cloud into the modern data warehousing technologies. So you can see here, this is a typical data warehousing example where the data is getting collected from the customer relationship management, enterprise resource planning systems, supply chain management systems, and there is an ETL. So just to say what is an ETL, it's an acronym like extract, transform, and load. So you do the extraction, you do the transformation, you do the load. So the extraction means it's nothing but getting the data out from the source system. Transform is to make the data standardized, then put the data loaded into the data warehouse. So the transform can extend just to transform the data to make it standardized to all the complex business logic you want to put in. It's based on the companies, how they are using it today and how they want to, how they built all their ETL pipelines as of today. This is the bit complex part in the overall ETL pipelines. And once the data available in the data warehouse, it will be made available to the user for their analytics purpose. So I just want to touch upon the ETL and what is evolving today as ELT. Why there is a big shift on this in this phase because of the nature of the modern data warehouses and the cloud computing. As we explained, the ETL is extracting the data from the sources, cleaning and summarizing and loading them into a target data store to have the insights and drawn from the clean data. Whereas in the ELT world, because we are not constrained about the storage, we are not constrained about the compute, and also we don't want to apply predefined rules even before the data available. So even a small mistake on the predefined rules can spoil the entire data. So the new paradigm is ELT, where we will extract the data from the disparate sources and we store the data immediately as soon as we extracted the data into the data lake without any aggregation in the raw fashion, so that we can use the data for different purposes as we discussed with the different type of analytics. Then the transformation will happen based on the need, based on the requirement for the specific report, and will make it available to the reporting or the analytical teams. So by doing this, we are not losing any information. At the same time, we also can get the benefit out of the analytics by applying the transformation in the later stage of this process. So what is a modern data warehousing? As we talked about, the ETL is slowly shifting from ETL to the ELT with the help of the modern data warehousing. And this is the technology stack from Microsoft offering, which provides this modern data warehousing possible for everyone. You can see here the ingestion and the preparation, which is the data factory and Azure Databricks. And the model service or the data warehouse is the Azure Synapse Analytics, and the visualization is the Power BI, and the data store using the Azure Data Lake storage. So we see here the four components, the top four components, because I just want to say that the four components, the core four components in the data engineering is the data factory, Databricks, Synapse Analytics, and the data lake store. Power BI is purely a visualization component. Though they are evolving the Power BI with Power BI Automate, we can have a separate session on the Power BI itself with all the different features Power BI offering. But we will be focusing more on the first four components here on the data factory, Databricks, Synapse Analytics, and the Azure Data Lake storage. This also enables us, because of the nature of these tools, you can see here whether it is a batch data or a streaming data or a real-time data, we can consume this data using the tools available for us in the Azure modern data warehouse systems. And we can make it available based on the requirements or based on the information, based on the business requirements and also the technical requirements provided by the business. For example, if someone wants to have the data at the earliest, the moment the transaction happened, to do some sort of a fraud analytics, we are not doing any coding or programming to make that happen, because Azure provides us the Azure Event Hub, which is a plug-and-play event pub-sub system where the data can be pushed into the event hub, and there is a streaming analytics where we can connect to these event hubs and run some SQLs to detect the frauds. And also more and more matured AI and data science models are coming out of Azure and all the other cloud providers, which can help us to predict even before the fraud can happen, or block the frauds as soon as the transaction happens, so that we can put the transaction on hold and not make that or revert back those transactions immediately. So as we started saying that data ingestion and preparation being the core of this overall modern data warehousing, Azure Data Factory being an orchestration or data integration engine, which is built within Azure using all the Azure native services. It's very simple drag and drop user interface, which can help us to connect different or disparate data sources. As we speak today, it can support about 100 plus data sources and 80 plus targets as a data targets. So you can connect, let's assume that we want to do an analytics on top of 3 different databases, one from SQL Server, another one from Oracle, another one from DB2. The Azure Data Factory has a connector. You can just connect using the credentials of those databases and ask which data has to be moved, and all this data can be pushed to a data lake. So we got the data now. Then the step 2 is to expose the database or expose the data lake using the mechanism Polybase as an external table to Azure Synapse, and any user can start accessing the data. So we have done that extract, and also we have completed the load using the Azure Data Factory. And there is no programming involved to accomplish. It's more of a drag and drop. All we need is what we need to connect and what we want to store. And the data lake storage, as we said, this is the data storage. You can think it as an external hard disk or your disk storage in your system with unlimited capacity, and also provides the POSIX and RBAC better security models, and also it's compatible with the Hadoop or the big data file system. So we can store a number of data with a different format because it's a files and folders, and we can just dump the data into the data lake storage. And there is a Databricks. This is where you need more programming expertise if you want to really transform the data using the Spark, open source Spark language to transform, because the Spark is the biggest computing engine, which also helps to do the machine learning and artificial intelligence, where you can read the data, transform to a greater extent, and also make it available for the machine learning and Power BI reporting services. We want to go back the previous slide. Just want to touch upon, if you're already a Java developer, you can use Scala to build this program, because the Spark is nothing but an API, and even Microsoft Visual C++ is also providing the Spark APIs right now. And you can use any language as a SQL, Python, or Scala as we speak as a native language within the Databricks ecosystem. And this is the Synapse Analytics. This is the new gen Synapse Analytics, currently in private preview, but is also used by many customers as we speak. So you can see here the Synapse pipelines is nothing but the Azure Data Factory rebrand and integrated with the Synapse Analytics. And Synapse SQL is nothing but a SQL interface. And Synapse Studio is kind of a workspace to integrate all this information. And Synapse Spark is something similar to the Databricks Spark, but you can use as an integrated environment. So all these components, they are connecting the Azure Data Factory, Azure SQL, Azure Databricks, everything into a single wrapper called the Synapse Studio, and you can use with the Synapse Analytics, which provides unlimited compute, completely separated storage and computing, and also very user-friendly interfaces using SQL to perform all your analytics in a scale of petabyte of data. So this is the Azure Analysis Services, which is used for the Power BI report, because the report has to be responded quickly, because that's the only component where the users wants to see a dashboard. They don't want to wait for a few hours to get the data completely transformed and come to them as a report. So the Azure Analysis Services helps to move the data and have this in a structured way so that the Power BI reports can connect to the Azure Analysis to produce the report. Again, in all these places, we are not talking about more of a programming, it's more of an orchestration and drag and drop tool usage to build this what we want to achieve on analytics. Because the way how this company started thinking, whether it's a Microsoft or any other cloud providers, they want to move the analytics towards the business rather than keeping it in IT's hands. So currently, there was a complete separation between the IT and the business from the data and analytics, and all these cloud analytics solutions wants to bridge the gap, and they want to come up with a unified solution. So even the users who has only business expertise, not much of technical expertise, can start using these tools, build the dashboards, whatever they need. And these are the three components we talked about. The Azure Data Factory can connect to the heterogeneous data sources, make the data available, and the Polybase can connect those data lake storage and they expose it as an external table. And SSIS is as good as the Power BI reporting services, which are Azure Analytical Services to make this data available for the reports. So in Azure Data Factory, in a nutshell, it has one component, the very critical component, which is called a linked service, which is nothing but from where we want to get the data and where we want to store the data. And also the data bricks if you want to do some sort of a transformation. Then we have a data set, which is nothing but the file format, whether it is a CSV or whether it is a JSON or whether it is an XML and so on. And the pipelines are nothing but connecting these linked services to the data sets to produce the data to be available in the target. And the triggers are kind of a schedulers where we can run this process in a scheduled interval or manually to execute. So trigger is, yeah, you can see here, the moment we run the trigger, the data is moved from the linked services or the sources to the data sets, and we can use parameters to dynamically build, and the integration runtime is nothing but the compute to support this execution. And the different data processing options for performing analytics in Azure, as we discussed about the Synapse Analytics, Databricks, Data Factory, Azure Data Lake Storage, and the Azure HT Insight, which is nothing but the Hadoop component within Azure ecosystem to support all the big data or orchestrations. If you want to have a unified owned by the organizations in the Azure platform. We already discussed mostly on the Azure Synapse and the Power BI. This is how the Power BI desktop will look like, and the desktop I will get publish the reports into the Power BI service, which can be also viewed in mobile or across the interface using the internet as well. So you can access the reports, you can slice and dice the way how you want to get the data. The underlying data for this report is going to be performed by the data engineer by connecting disparate data sources and make the data available on the data warehouse.
Yeah.
I think I pretty much give the 1,000 feet overview on the different components available in Azure to perform, and what sort of expectations the organization have from the data engineering perspective for the individuals to make the data available, being a core responsibility of moving the data from the disparate source systems into a common data warehouse. Being said that, I'll hand over the slides to Tanesh and to go in depth on the different training and certification offerings and what we cover as part of AMEA for the data engineering.
Thanks, Siva. Excellent. Thanks so much. See, whatever we have discussed now, everything is an invaluable resource and very, very limited skilled people available in this market. Okay. So we started with what is data, which is a very elementary thing. And when Siva concludes, like he connected all the pieces and offered us a presentable way, like this is ingestion, this is what processing, this is what storage, this is like something kind of a PhD level kind of information. So we covered everything like in a given time in a 30 to 45 minutes, but many people struggling to understand this more than a year. Okay, that's what here. Thanks, Siva, so much. Thanks. Even though I'm working in data industries, when I'm hearing your the way you are viewing your perspective, it gives me a new insights for me. That is the wonder thing in the data. So that's the reason data is keep on evolving, and there is a lot of new people are needed here. Okay. To move on further, yes, there may be a lot of questions comes. Okay, Siva talked about very precise and essenced way. what are all the tools available, what are the technologies available. But as I said, it's kind of an, you can analogous like an, oh, it is some kind of an English language. The grammars, if you take, there is an verbs, nouns, blah, blah, they say, but that's all fine. But my purpose is I want to be an talk in English or write a sentence, right? So there is a formal way. Instead of you can't able to go and start everything. So that's why we are recommending and we are suggesting all our candidates and clients, even the corporate clients, make the resource, make their employee to go for formal training. The reason is in the training only they organized, they presented in the way how the things you should work. Okay, I keep on using the same analogous to everywhere. Okay, the scissor had the capability to cut the same way for axe also, but if only this knowledge is not sufficient, someone to able to cut something, right? They know that the scissor can cut, but what scissor will cut? Scissor will cut only papers, okay, or small things. If somebody trying to use the scissor as a tool to cut a small branch in a tree, maybe a stem in a tree, yes, it will cut, but it will take more time. Or if it tries to cut a big tree, definitely it won't cut, it damages the tool, okay? Vice versa. I have an axe. If I'm using axe to cut a tree, that is excellent. It will cut in very fast. But if I use the same axe tool to cut the paper, it spoils everything, right? This is what truly happening in the industry. People heard and have very limited knowledge here and there, but they don't know how to use the tool. Okay, so that's where many projects are failing. That's why we strongly recommending the corporates also, even the peoples also go the certification training, because the certification training exactly says what is do's and don'ts. All this luxury, like Siva explained, you don't need any programming background. You don't need any that complex learning, but you should know how to orchestrate. You should know how to, which one should put in what order. Okay, so those all is that's why these companies, Microsoft, Amazon, everyone is to educate the people resources they are offering in the way of the certifications. Okay, I'm sure some of my earlier students also here, and now they realized what is the need of the certifications. Okay, so in that aspect, how you can streamline yourself to becoming as a data engineer. Our strong recommendation is go for take the certification exam. Also, many people used to ask us questions like, oh, there is a lot of resources available. Can I train by myself? That resources is distracting. It is not in structured organized. That's why whether us or somewhere, but we strongly recommend go and take as in some instructor guided way kind of an learning. Okay, that is the way you come to know. It's a kind of an learning how to drive a car through a video definitely will not help you unless you not sit inside the car, put your hands on the steering wheel and change the drive. Okay, both is completely different. Okay, if you watch only the video and you can't able to drive the car on the road. Okay, so with that, I will talk about from certification and the educational perspective, how you can equip yourself, what Microsoft is offering. For data engineering perspective, so Microsoft is offering 3 certifications. One is DP 900, which is a fundamental, data fundamental. They are discussing about whatever just now Siva said. It is a 2-day training program. It is the very much appropriate for the managers or the CTOs, or somebody wants, they don't know anything about the cloud, they can start from here. Or if you already having a fundamental, Azure fundamental, then you don't need to go here because you already know that how this cloud technology is working. So that's why any one fundamental certification is more than enough to progress yourself in this specialist in this area. Okay. So those who doesn't know anything about Microsoft Azure, then we strongly suggest you can take this exam. Otherwise, if you already AZ 900 already you learned and you have certification, then you no need to go here. So that is AZ 900 is for a cloud engineer, cloud technology. This is for data engineer. For data engineer, we strongly suggesting this one, DP 200. This DP 200, we are covering whatever just now Siva said, we are covering about how to use, how to configure, okay, everything with the hands-on. So that's why DP 200 is the Microsoft certification. They are talking about how to implementing this Azure data solutions. Okay, how to work on Azure Data Factory, how to work on Synapse, how to work on Databricks, okay, everything. Okay, so they are giving an the entry level of that hands-on experience in this DP200. And then there is another certification, DP201. This is for more for an architect pupils, design for the data solution, design and design Azure data solutions. Okay, so this is mainly for the architects, or even it is good for a senior level of data engineers. Okay, so this is the 3 certifications what Microsoft Azure is offering. I think we are already moving ahead of the time. I can try to move a little forward. For fundamental, this is the core things for the fundamental certification. These are all the core concepts they are talking. Core data concepts, work with relational data, non-relational data, describe how to work with in Azure and analytics workload. Okay, those who are freshers, those who doesn't know what is data, anything, then they can try with this course. Okay, otherwise AZ 900 fundamental